Hi, everyone. My name is Mark Vina, host of the SmartTech Check podcast. Today's Monday, November 6th, 2023. The growing importance of smart technology in automobiles is transforming the way we drive and interact with our vehicles. From advanced driver assistance systems to in-car entertainment to connectivity features like GPS navigation and remote control, smart tech enhances safety, convenience, and efficiency, heralding a new era of automotive innovation. Joining me for a robust discussion on the role that tech is playing in today's and tomorrow's cars is Satish Ganesan, SVP and GM of Automotive VR and Chief Strategy Officer at Synaptics, a leader in this important tech sector.
Glad to be here.
No, I'm glad to have you because this is a topic that I think is incredibly underappreciated. We're going to dive into a variety of different topics. In all, transparency, I used to work at Synaptics not too long ago, but well before, Synaptics kind of got involved in the automotive space. It's in so many different spaces. It's a completely different company from the company I worked at a long time ago, but it did give me an appreciation for the importance of ingredient technology in smart devices. What I like to do, Satish, is before I kind of walk you through the topics we want to go through, let me bring up your background because I'd love you to talk a little bit about yourself. You've been around in the technology industry for some time. So why don't you walk us through for a couple of minutes, your background?
Sure. So I come from primarily a product background, and I am both the Chief Strategy Officer, as you said. I play a dual role here, the Chief Strategy Officer of Synaptics, partly playing a role in the transformation of the company from a mobile-centric company to a more diversified IoT company. And part of the diversification also included the diversification into automotive and so on, taking our technologies into that space. And recently, I also took over the role of the general manager of the automotive and VR business unit as well, because we think that's an important vector for Synaptics, where we can actually grow more into the car ecosystem, because the car is simply an IoT device on wheels, if you think about
Yes.
it these days, right? So that's kind of where it is. And prior to this, I have been in a variety of roles at Broadcom and startup companies like Kisa and Tylera and so on, spanning the spectrum, mostly focusing on product marketing and running the businesses and so on, spanning it from data centers all the way to wireless connectivity and Wi-Fi and Bluetooth. Hope to use all those experiences as we delve into these parts of the business.
Right. Well, I mean, you have the perfect background for this type of pivotal role, and it is a pivotal role because, as you said, I mean, cars are really and by the way, that didn't happen 2 years ago. For probably the last 10 years or so, cars have really simply been computers on wheels. And now as we get into EVs, now as we get into other, self-driving cars, which is really the next wave that's coming, the amount of the bill of materials in a car is incredible compared to what it was, 20 years ago. And obviously Synaptics plays a pretty important role and will play a very, very important role going forward. But let's get into some specific topics. And I always like to, look at these problems and challenges and opportunities from a trend standpoint. And certainly, smart technology in cars is not a new thing. If anything, there's numbers of subsystems in a car. But from a Synaptics perspective, you've been a major player in automotive displays. What are some of the trends that you guys are focused on?
Yeah, you're right, Mark. And primarily, I think in the automotive, we focus on the display subsystem. That's kind of where our focus area is. And if you look at the trends, primarily, as you can see, as the cars grow slicker and more basic features come into these cars, the displays are getting bigger and bigger. So that's one thing that you see in cars. So there's more and more displays that are getting bigger and bigger, and the displays are becoming brighter with better contrast ratio. So the quality of the displays is also getting higher. So traditionally, the wire Synaptics plays in here has been the business that you were involved with when you were at Synaptics. It was the touch and the DDIC and so on that were there previously, long time ago. I think those businesses were what we first went in the automotive system, where each of them were discrete components. So we had a discrete touch and discrete DDIC and those. But we introduced this product called Touch and Display Driver Integrated Chip, that integrated IC called the TDDI. And the market for TDDI now is expanding because now you can actually have an integrated chipset that covers both, touch and display in one chipset, and that is actually the dominant portion of the market. That's kind of where you're seeing in the slides here. That market is
Mhm.
continues to grow and have a dominant position in that market where discrete devices were used for lower sized panels. The bigger panels use integrated touch and display drivers, and in the premium most segment of these panels, you're starting to see OLED trying to make way into automotive as well, right? And so we
Right.
play primarily in the TDDI segment, in the OLED segment. We do have chips for discrete touch and DDICs, though I think those things will decline faster, and the TDDIs and will grow, and the OLED starting in the cream of the cars.
Right. And when you look at it from a macro standpoint, and you're looking at it from an ingredient, device standpoint, the reason why this is so important is that ultimately over time, you look inside the average car, you're going to have multiple displays. You already do have multiple displays. And,
That's right.
and by the way, we're just talking about the front of part of the car, the passenger side. You go into the back of the car. Now
Yep.
it's going to become almost like a movie theater on wheels. And that has all kinds of implications from an aftermarket revenue standpoint. That's why a lot of a lot of the car manufacturers, and that's a separate podcast, are really kind of challenged about
Yeah.
what do who's going to own that space. But it has to be a really good experience, and it has to be a very responsive experience. And we're not even talking about, by the way, the windshield on the car, which is another opportunity. You've got heads-up displays, of course, that are very popular in cars, but that's
That's right.
generally that's done with projectors that are built into the top of the dashboard. That ultimately will get usurped over time. So these are really interesting categories. And so, do you have kind of a view on, just from a vision standpoint, where Synaptics really wants to be the prominent player in all those deployments of display technology in the car?
That's right, and I think you actually summed it up pretty well. So overall, if you look at all the displays in the car, so you think about the information, the central information displays. That's kind of the one that sits in the center of the car. The displays that sits behind the steering wheel is the cluster displays. Traditionally, those were
Yeah.
just displays that showed you the speedometer, but now it shows you more and more information and can be configured. So that's become a digital display that you want a good contrast ratio on. You made a good point on a couple of other displays, what's called the RSE, or the Rear Seat Entertainment System, right? And
Yes.
so those are also compelling displays. But if you look at what's happening in those displays, it's an interesting place where you want the kids in the car in the back, to actually be able to play games with Bluetooth controllers and things like that. So that becomes an interesting place where the latency and the refresh rate and things like that become important in those displays. And in the head-up displays as well, as you said, it was projection based displays, right? And so, but and reflective displays there, that based on projection. But even that, there's a trend in the market where the HUD displays are potentially going to reflecting a TFT and an LCD TFT display with local dimming and so on. We'll talk about that technology in a bit. And that actually also is a screen space. And if you look at that screen space, traditionally it's in front of the driver alone, but you can think about that screen space in a smaller area, or the windshield space, if you will, to be pillar to pillar as well. So one of the things that in display sizes, the displays are growing. So sometimes you see the cluster and the central information display combined into one display, and the other piece is a wall-to-wall display, right? So the displays are going wall-to-wall as well. And I think we show a slide for the following things where the display sizes are getting larger and larger, and so the displays are going wall-to-wall as well. So display sizes are getting larger, and multiple displays are getting merged as well. So there's a lot of trends going on in here. And what Synaptics wants to do is enable all of these displays with the best performance, with the optimal power. Power becomes very important at that particular point of time. So optimal power is important because if you look at the trend of EVs and so on, there's that part of the power becomes an equation, even if it's one portion of the design. And then we want to control the entire connectivity aspect of it as well. So that's kind of where Synaptics is playing from an overall vision perspective.
Right. Well, so let's kind of dive deep into it. And you've kind of hinted at it. It's important to talk about the impact to EVs. I mean, EVs are growing in popularity. Um, there's going to be more competitors in the space over time, which is a good thing because prices will come down. I always look at it from a competition's good standpoint. But specific to EVs, the technology solutions that you provide, or the ingredient solutions you provide, have a major importance of creating more efficiency in the car, extending battery life, because battery life in EVs are critical. You've got multiple, in the average EV, there are multiple subsystems, some of which they always don't talk to each other. That will get, optimized over time. But talk about specifically from an EV perspective why this capability is so important.
Yeah, I mean, I think you hit on that point when you were talking about EVs. From an EV perspective, primarily one of the things that is very important in EVs is the battery performance. So traditionally in cars, power was not a vector that was,
That
a
important.
key
Yeah,
focus area, a key focus
right. It was a
area.
priority. Hmm.
Yeah, with the priority, right? But if you look at what's going on right now in some of these displays and the requirements that are coming, we are seeing from the OEMs and tier ones in the automotive segment is the requirement that, hey, the power of these panels, the power of the entire system be optimized while you're delivering the best performance, right? So they want the performance associated with it, because these cars are also starting to look very good, right? So the interior is, like you said, an IoT device on wheels. So you want the performance to be really good, but you want that to happen at a power profile that's actually pretty significantly lower, so
Right.
that you don't have range anxiety, if you will, on EVs, right? So even though there's multiple subsystems, right? If you have even though you have multiple subsystems, some of these display subsystem as well is important. So every watt now matters. It's not that every watt doesn't matter; every watt matters. And so
Well,
from an EV
yeah,
perspective,
and Satish, let me just jump in for a second. The reason why because we talk about performance and sometimes those words go over people's heads. When you're when response time and minimizing latency is critically important. It's not just about saving power, as you know, and you've been
yeah,
articulating it quite well. You have to provide best in class performance, because especially in an EV or a self-driving vehicle over time, the information can't be displayed on a display even a millisecond too late, because it could impact safety. So it's a
that's
challenge,
correct.
because you have to provide great performance at a lower power profile.
That's exactly right. So yeah, that's exactly right. So you cannot compromise on performance because of all these safety requirements and so on, which is actually very important. As this cabin becomes more and more digitized, you want to make sure that that doesn't compromise on the performance, and latency is extremely important, as you said. And the performance of the touch or performance of your display is also important. So you cannot have part of the display failing and your important vector not showing up in terms of your warning sign or something like that, right? So you cannot have something like that happen either. So you need the performance to be really, really good. However, you want to do it at the lowest possible power. And I think that's the
Yes.
solution you want to optimize. And then for doing all of those things, you have to build the right combination of technologies. And that's where the chances for differentiation comes in. And so you build better technologies to differentiate for power, for performance, and giving the best solution, overall system level cost and performance. So that's the focus area for us. And that's why the EVs are driving this trend, but as the EVs drive it, it's actually going to get adopted in all of the cars as well. So I think
Yes.
that becomes that's a standard things that flows down, right?
It's interesting how I want to hit the next topic, but it's really interesting how EVs, because they're, that's where a lot of the innovation is happening. It will very quickly trickle down to cars that are outside the EV space. It's very interesting.
Yeah.
So, getting back to, Synaptics from how it's addressing these trends and the challenges that are associated with it. I've got a slide up here on the smart bridge technology that you folks have, but
Yeah.
let's talk. It gets a little technical for the average person, but let's talk a little bit about that, how you're deploying that to address these challenges.
Yeah, I mean, I think fundamentally, if you think about it, you're driving your car. You have different modes of these cars. Sometimes you have your displays that are acting in the daytime in the day mode, and if you look at your displays after around sunset time or something, they switch their mode to a night mode or something like that. The displays change the way they're projecting. And now, what you want in these displays is traditionally, you legacy devices. You have this information controller unit, right? That transmits this whatever should be displayed on the CID or the cluster, the central information display or the cluster. The CID is the central information display, and it shows that. And you have TDDIs that are basically display and touch drivers that allow you to do touch or display and so on, right? But the main thing here is the reason we like our phones and we like our iPads and iPhones and so on is these are all OLED displays. So they are driven by LEDs, and each LED is controlled by on its own. So it gives you the best contrast ratio. Now, what
Right.
you want to do is, if you want that level of blacks looking blacker and whites looking whiter, right? Because you have different colors that are coming through, your speedometer is moving and so on. You want the
Right.
contrast ratio to be good, but you don't want to compromise your brightness.
Yes.
And traditionally, when you turn things very bright, what happens is you get an effect called the halo effect. So when you have a black background, you have a white spot, and you turn the brightness up, you'll find the halo behind the white spot, and you don't want to see that because it'll make things worse. And when you want, same thing in the reverse way as well, right? So you want to have technologies that will enhance this. So what
Right.
we have is what's called the local dimming technology, which is used in TVs and so on, if you will, to make the blacks look blacker and the white looks whiter. But essentially, it basically is a 2D backlight that sits behind the display that enhances the system performance with mini LED 2D array sitting behind it. So based on the image, it can appropriately and dynamically change configure the brightness of the LEDs that go behind it, right? And so that technology, we do it uniquely well because we do it as a combination of hardware and software, not just typically that's done in software, and that causes latency. You talked about latency before. That creates latency. So if you're optimizing the contrast ratio of an image that was shown a few frames ago, it won't look that good. So you have to reduce the latency. So we do a single frame latency, if you will. So whatever you're seeing in the image, our image processing algorithms, the TDDI chips, optimize the image and how it looks in combination with the local dimming technology that optimizes the LEDs that are controlled from behind the 2D array. And so this gives you the best contrast ratio at the highest brightness possible and reduces all these effects like halo and so on. And so it gives, and also can make up for some, if some LEDs are broken, it can actually compensate for that and so on. So it's a complex. I threw a lot of technical terms here,
Yeah.
but
No.
complex technology. But the important thing here is it's done in such a way that you can optimize the power. So you can optimize the power of the panel and the system level power while also optimizing system level cost. So our
Yes.
technology, because it's done in hardware, allows you to reduce the number of LEDs that are required to manage this display. So when you reduce the number of LEDs required, it reduces the system level cost. So on a bigger displays, we can save something in tens of dollars in terms of the overall system cost. So practically giving you this whole thing for a system level savings, in fact, right? And also optimizing the power of the entire panel and so on. So it's
Sure.
an important technology, and it's important to address all these concerns and displays and safety. And but you can do that by improving the manufacturability, improving the system level performance, while optimizing the power and so on. And that's kind of our focus and our differentiation as well.
Now, the other thing that's really important, and this is something that I cut my teeth on, years ago, back when the touchpad was a pretty important part of
Yep.
Synaptics' overall business, and notebooks, ruled supreme. What's Synaptics, and I don't think a lot of people appreciate this, and I've told your CEO Michael Hurlston this many times, and I think he agrees with this. I suspect you'll agree with this. Is that Synaptics is an unusual company. It just doesn't sell a piece of silicon. Even back in the day when I was doing running the PC business, that our success, and we had in those days 70-80% market share of notebook PCs. It was a unique combination of firmware, the ASIC itself, and back in those days, I think we had a couple of ASICs to service multiple markets, and that's nothing like what Synaptics is today, which you have multiple chip solutions. But there was software, there was usability. You don't sell a part to an automotive manufacturer and say, "Hey, see you later." It's a plug and play. There's a lot of engineering proficiency. It's important, when a supplier like a major car manufacturer, whether it be a BMW or whether it's an Audi or whoever that car manufacturer might be, if they're putting your part in a $70,000 car, they cannot screw up the development timeline, the integration. So, talk a little bit about why that's so important, even in the automotive space.
Yeah, I mean, I think it's you put it pretty well. And if you think about Synaptics, so just stepping back on Synaptics, not just automotive, right? We basically say, the three things that we do is, we do sensing, we do processing, and we do connectivity, right? Those three things define, what an IoT device is. And the processing portion of the equation, right? It's not just basically when you typically have just a sensor, you take the sensor, you do everything in hardware, and it's a component sale, right? But that's not traditionally what we do, right? We do the sensing in terms of the display. We do display drivers, but we sense the displays, and we figure out, we do touch sensing as well. But we take that and we actually have a significant portion of the algorithms running in firmware to compensate for the environmental conditions, to compensate for the conditions of display noise that impacting touch, and so that the performance of the solution can be the best possible solution. So there's a lot of optimization and performance tuning that can be done in software,
Yes.
both as a default framework that we provide to our automotive vendors and so on, which is why the quality of our solution is pretty good, but also
Yes.
be able to work in different environments in these cars or in any other device for that matter, right? So this fundamental layer that we have in terms of being able to be primarily driven by hardware assisted technologies like local dimming and so on, but have sufficient ability to basically address a stack layer on top of it to fine tune the solution, so you can easily get to tune it for your particular condition or your particular situation. I think
No,
that
I
part
think
of it,
that's absolutely
yeah,
true. I mean, that's true in smartphones, by the way, and you know
yeah,
that well. And and it's an interesting. We could talk about this forever. We could have another podcast
yeah,
just on this topic. Is that this really varies almost not only from manufacturer to manufacturer, but region to region. You may have requirements in South Korea that you may not have in North America or Europe. So that fine tuning element, which I don't
yeah.
think a lot of people truly appreciate it. You certainly appreciate it because you guys have got expertise in that area. Is really, really important. Very, very important.
That's
There is
right.
one other
And
topic
yeah,
that I want to address before we get off the podcast, because we only got about 3 or 4 minutes left here. Is that it's we've been talking about displays, wireless connectivity, or just connectivity in general, is an incredibly important role that Synaptics is playing. And again, it's going to become even more critical as cars become more self-driving oriented, because obviously you need great connectivity, whatever that technology capability is, to provide a really safe and incredibly efficient experience. So let's talk about that from an
yeah.
automotive standpoint and the connectivity expertise that you folks have.
Yeah, I mean, I think this is very important for us, and we talked about a little bit during the Investor Day as well. I think our focus areas are, we interface to these sensors, and then we do processing and connectivity, and the wireless portfolio for us, came from initially from an acquisition that I did on from a Broadcom IoT assets that we acquired, and we have a very compelling set of chipsets, the industry leading performance, power, and cost profile that we have for our portfolio. And one of the areas that we believe that we can address, of course, is, as we talked about displays, as we talked about RASIs, entertainments, and so on. You understand that
Yes.
people are going to have controllers, and they want to have Bluetooth to connect your music while they want to play games with their controllers and so on. So there's the newer technologies like dual Bluetooth and so on that's important. And as Wi-Fi becomes more and more important for technologies like CarPlay and everything else like that, you want to have connectivity inside the car as well. And so as we go to newer technologies like Wi-Fi 7 and so on, and being able to not just give connectivity to people in the car, but also connect to the network at the same time. So do real simultaneous dual band with dual Bluetooth and things like that. We have the right technology players. We are already a good player in IoT segment. And I think in automotive, I think we have the right technology in terms of our features and performance, and leading the category in that. I think that we can make some noise in that area, and I think that's an area that we will actually also focus on, along with other stuff like using the displays as a platform to create sound, right? So we introduce some technology called Resonate and so on. There's other areas where we can use the display as your speaker, right? So I think there are areas that we can focus on that Synaptics will also grow into in automotive.
Right. No, it truly is amazing. And in the 30 seconds we have left, is there anything left you'd like to, as a takeaway, you'd like the audience to kind of have an appreciation for, whether it's automotive or wireless or just Synaptics in general, to wrap it
Yeah,
up?
I mean, I think we are overall. I appreciate the time. Thank you very much. It was a very great conversation, and I think we focus in areas on and technologies that can optimize system level cost, system level performance, and focus in on areas of processing and connectivity wherever they are, whether it's in the car, whether it's in your home, whether it's the enterprise or anything else like that, right? So I think those are the areas that we focus on, and we are hoping to people in this podcast are already using Synaptics products in their day-to-day lives, and I think we think that we are well set up for more growth as we go.
Well, Satish, we'll have to wrap it up there. Thanks for taking the time to our viewing audience for listening to today's podcast. Please make it part of your day or commute. Please make sure that you hit the like and subscribe buttons at the end of today's podcast, or use these convenient on-screen QR codes to connect with me. You can also follow me on X, formerly known as Twitter, at Mark Vina Tech Guy. Satish, thanks again. And until next time, everyone, have a great week.
Thank you.